Hey everybody. So in this last video, we're going to discuss the sympathetic pathway or the fight or flight response. Specifically, the neural signals and the different hormones associated with the fight or flight response. So if you see a fire and you freak out and you're like, "Oh my god, there's a fire. I got to get out of here." Right? That's fight or flight. What is happening in your brain and in your body to trigger that response to get you ready to run, right? Or if you needed to fight for your life, what is going to happen in your body to trigger that? There's one really important thing to keep in mind, and that is going to be that there are two major ways that signals are sent through the body. Just to remember, you have hormones and you have neural signals. The hormones is what we've been focusing on. They're indicated with these blue arrows. And then the neural signals are just the nervous system. And those are with the orange arrows. So let's just start off with the first part, which is number one, stress. Something happens in your environment. You see something, you smell something, you taste something, you hear something, and it stresses you out. That signal is going to go directly to your hypothalamus, right? So maybe you eat something that you were not expecting to, something really hot, something really spicy, right? Something really bitter. Maybe you smell something that like smoke from a fire. Maybe you see something that scares you, like you're driving and someone swerves into your lane, right? All these things can signal the hypothalamus to trigger the fight or flight pathway. From here, there's a couple things that happen. Let's start with the left hand side. Your hypothalamus is going to send an electrical signal or a nervous signal down through the adrenal medulla or adrenal medulla, however you want to say it. From here, your adrenal region is going to release epinephrine and norepinephrine, right? And this is what's going to give you that fight or flight scenario, right? So it's all because of a nervous signal that gets sent to that adrenal region. From here, your blood glucose goes up, more sugar, you have more energy. You're going to increase glycerol and fatty acids, again, more energy. Your heart rate goes up, your blood pressure goes up, your breathing rate goes up. You're starting to see what's going on here. This is all triggered because of the epinephrine that's being released from the adrenal glands. On the other side, this next part's strictly hormone. So again, your hypothalamus is triggered from whatever reason. You see something, hear something, whatever. From here, CRH is going to be released. Again, this is a releasing hormone, corticotropin releasing hormone. So its job is to tell the anterior pituitary to release ACTH, adrenal corticotropic hormone. With this hormone is then going to be released, and it is going to go to the adrenal cortex as well. It is going to release cortisol. Cortisol is another hormone. And when this gets released, we're also going to see things like increased concentrations of amino acids and fatty acids, as well as increase of glucose that is created from non-carbohydrates. So in other words, you're going to start to create even more glucose from non-glucose things. These two scenarios work together. They help each other out. There's also a terrible illustration. They're going to work together to make sure that you can do everything possible to fight or to run away from a situation, right? And it's a combination of nervous signals as well as hormones that are being released into the body. If you want to finish this off and end it, you want to stop this from happening, just like we talked about with the negative feedback loops, your brain, your hypothalamus will recognize this and then stop releasing the CRH hormone, as well as this signal here with the nervous pathway is really quick. So once that's done, you're no longer sending anything to your adrenal region, right? So that part's the quick part. But once it gets into the blood, the CRH will stop being released once the hypothalamus tells it to stop sending the signals. Right? So it's It's a lot of the same scenario going on over and over again, a lot of negative feedback loops, and they're going to tie together for, at least in this case, fight or flight. The last thing to keep in mind when we're talking about the neural signals versus hormones, the neural signals are very, very quick, whereas the hormonal signals are slow and they continue to release until something stops it, right? So if you see a burning building, immediately you're going to send that signal to the adrenal region to release epinephrine. But that's very fast response, right? You don't need to keep staring at the fire in order to keep your adrenaline up. It's a one and done. You see it, it registers, okay, now I'm ready to run. However, over here, once that hormone gets released, then it's going to continue to release more and more until eventually you realize, okay, I'm out of the area. I'm done running from this fire. I'm out of the house. You're still going to have your heart rate up. Same over here with the adrenal medulla, right? You're still going to have your heart rate up. You're still going to be breathing fast. You're still going to have that fight or flight response. It's going to take some time for your hypothalamus to register that and then eventually stop sending the signal, right? Once that happens, then slowly everything goes back to normal. So hormones take more time, whereas neural responses are really quick and short. All right, so that is the end of this. If you guys have any questions, please let me know.